Okay, so this is part 2 of linear equations, and we're going to talk about real life applications. So, in other words, story problems. So it says you are controlling an unmanned aerial vehicle, UAV, for surveillance. The table shows the height, y, in thousands of feet of the UAV, x minutes after you start its descent from a cruising altitude. Write the linear equation. Oh, it says function, but remember a linear function is the same as a linear equation. Interpret the slope and the y-intercept. So just like before, we're going to do y equals mx plus b, where we need to find out what m is first. And remember, m is found by doing y2 minus y1 over x2 minus x1. So I'm going to pick two of these. Pick 2 points. It doesn't matter which two. And I'm going to say this here is point 1 and this here is point 2. So my y value is subtracted, 60 minus 65, over my x value subtracted, 0 minus 10, equals negative 5. Oops, did I do that backwards? 60. Yep, this has got to be 10 and that one's got to be 0. See, you have to make sure your values are in the same order. See, 60 and 10 go together. 65 and 0 go together. All right, so when we subtract this, I get negative 5 over 10, or m equals negative 1/2. Okay, so I have my first part, y equals negative 1/2 m. And remember, b is the place where x equals 0. So looking at this chart, you see x is 0 right there. And when does that happen? It happens at 65 feet. So we are going to have here negative 1/2 m plus 65. Now interpreting the slope. Remember, whenever we interpret the slope, we take the slope itself, negative 1/2, and then we do the y values, because of y is on the top, y per x. So y per x. We're going to look for the y values, and this is thousands of feet. So we say negative 1/2 thousand feet per, what is the x value? Minutes. So we say it goes down 1/2 of 1,000 or 500 feet per minute. But this negative sign means it's going down, which makes sense because our UAV is descending. Okay, what is the y-intercept? Y-intercept is the place where the x is 0, so we're looking at this point and trying to interpret it. And again, the y value is the height in thousands of feet. So you would say the UAV is 65,000 feet. And when is that? At time 0. What is time 0? Time 0 is when you start your descent. So it says the UAV is 65,000 feet at the beginning of our descent. All right, so let's look at another one. Oh, this is the same one. It says we're going to take these points and graph them. So 0, 65, we're going to put that on right there. And then 10, 60. And then 20, 55. And then lastly, 30, 50. So we graphed those points, and you see that the slope is negative. It's going downhill. Because the time cannot be negative, we don't need any points out here. We don't keep going up this way because it doesn't make sense to have negative time. Okay, so only positive values will work. And then this last thing says, find the height of the UAV when you stop the descent after 1 hour. So 1 hour equals, we got to put this in minutes because it's not over here at 1. We need it at 60 minutes. So if our chart here is going down a half every my line isn't very good here. Every whatever 10 minutes it goes down by a half. So here we see at 60 minutes it would be right here at 35,000 feet. Or we could do that by using that equation that we made on the last slide, which said y equals negative 1/2 x plus 65. If we put 60 in right here, let's get rid of this. If we put a 60 in there, plus 65, whoops, clear that, plus 65. So half of 60 is negative 30, plus 65 equals 35,000 feet. So we have the same answer.